Now it's time to focus on the smart contract, where we actually store data on the blockchain and what is allowed to change that data. That's what the smart contract application is all about. It's really just defining what fields of data we want to store, how much it costs to change it, and how to actually change it. What piece of the data changes whenever the button is clicked. Now, there's some other things that matter here, but ultimately there's two files in play. We have counter.sol, which was created by Forge, and counter.s.sol, which is the deployment script. We need neither of these, so it is perfectly safe to delete this. Let's go ahead and right-click, delete, and move to trash, and then right-click, delete, and then move to trash. And you may be thinking to yourself, well, what are we going to use? Well, I actually have sample code that you can follow along with right here. It's github.com/dataknox/monad-lightswitch. Let's start with the actual smart contract itself. This lives in the source folder, and then we see there's a file called LightSwitch.sol. That's not the Sol coin, that's Solidity, the programming language. So what I'll do is I'll jump back here, and under the source folder, I'll right-click and do New File, call it LightSwitch.sol, like so, and then I'll copy the guts by clicking on the Copy Raw file and paste it in. I'll save this, and you'll see I don't have syntax highlighting. It's a great opportunity to jump into your extensions and install a Solidity extension like so. So let me install this. We trust the publisher and install. It should be installed now. When I close this, there we go. Now it looks pretty. All right, so we've got the LightSwitch file. Now what I need to do is I need to get the deployment script as well. So I'll jump back to the source code, expand script, expand LightSwitch.s.sol, copy the guts, jump back here in scripts, create a new file called LightSwitch.s.sol, and I'll paste that in right there. This is just a deployment script for when it comes time to actually publish this script or this smart contract to the Monad blockchain itself. That's what this is doing. We have imported the LightSwitch class object. We've instantiated a new LightSwitch that is of the type LightSwitch. We are deploying the LightSwitch to a specific contract address, and that contract address is what you will need to develop your front end. That is the most important output in all of this when the deployment happens. So this is the guts that just brings the actual deployment to life. What about the actual data itself? We're using Solidity, at least version 0.8. We're creating a new smart contract object that is of the type LightSwitch. That's what we're defining. And it stores Boolean data publicly called isOn. Is the LightSwitch on or off? By default, we set it to a default set of data off. The switch is off by default. Then we set a public toggle price. Now the interesting thing here is it says 0.5 Ether, but this is actually using Mon under the hood. That is really, when we see Ether here, coming from the Solana world, this may be foreign to you, this is really saying whatever the native coin of the blockchain is. In this case, it's Mon. So when we say 0.5 Ether, because we're actually pointing to the Monad Testnet, it'll be Mon. So there's going to be an event, and that is that the switch has been toggled. It creates a new state that is Boolean, it's either on or it's off, and who the user was that actually did it. That's the address that's used here. The function that actually does the stuff, which is toggling, this is a public function that is also payable. It is required that there will be a message that says this is the toggle price and you must pay this. When the button is clicked, what does it do? It takes isOn, whatever that value is, which is currently default, and it changes it to not isOn, which means it'll become true. Or if it's true, it'll become false. And then this actually performs the SwitchToggled event, which is what we set up above. So the event is SwitchToggled. It submits the new value for isOn and who the sender was. See, these are the two parameters that it takes, the new state and what the address of the user is. Our smart contract will also allow the web application to get the current state of what the address is. Very simply, it returns a Boolean value, which is whatever isOn currently is. That way, whenever the website launches for the first time, it'll be able to see if the light switch is already on or off by default, and then allows the toggle function to change that. Now, this part is kind of interesting. We're spending 0.5 Mon to change the coin. Where does it go? Well, it's ultimately going to go to the smart contract owner. And here we set who the owner is, and then we allow that owner to withdraw those funds to their wallet. So ultimately, if people are paying to change the smart contract, the owner of the smart contract can then withdraw those funds to their own wallet. That's what we're setting here. So this is kind of just a brief flow of what the smart contract looks like, and the deployment script as well.